Good day, students. In this clip, we're going to be going over some examples to get you ready for the upcoming test. So let's take a look at question 1. Has to do with the quadratic formula. So solve the equation negative 3x squared minus 4 equals 4x. So before we start solving any quadratic equation, we have to put it in standard form, okay? So what's the standard form? It's the form where we have ax squared plus bx plus c equals 0. So we have the equation equal to 0, and each term is arranged in descending order of degree. So the second degree term comes first, the first degree term, and then the 0 degree or the constant comes last, okay? So we'll look at this equation we have right here. We have the second degree, and then we have the 0th degree of the constant. And on the other side, we have the first degree term. So we need to do two things here. First, we need to move this term, this first degree term, to the left side, so it's equal to 0. And we need to arrange every term in the order of descending degree. Okay? So in order to move this to the left side, we'll subtract 4x from both sides. Okay? Now, if you take a look at the left side, let's see what can we combine. The second degree term has no term to be combined with, so we'll bring it down, negative 3x squared. This is a first degree term. There's no other term of first degree here to be combined with, so we'll bring it down. And then just bring down the constant, okay? On the right side, these two are inverses, so they add up to 0. Now we have a standard form, okay? So assuming we didn't know to use the quadratic formula for this problem and wanted to try factoring, we would have made ourselves an x. The AC method. On the top, AC will have positive 12, and on the bottom we'll have negative 4. And then if we exhaust the possibilities for 12, we know that 1 times 12 is 12. This gives us 13 or 11, not 4. That doesn't work. 2 times 6 is 12. Can we combine positive 2 and positive 6 to get negative 4? And combine them, multiply them to get 12. It's impossible. Because if any of these two is negative, the top is going to be negative also. So none of these work. 3 times 4 doesn't work either. We have a complete set of factors. So this is a prime quadratic. It cannot be factored. So we have to use the quadratic formula. All right. So the quadratic formula again is x equals negative b plus or minus the square root of b squared minus 4ac, and this whole thing over 2a, okay? To use this equation, keep in mind the fact that a is negative 3, b is negative 4, and c is negative 4, okay? So put that in the equation, you'll have x equals negative b, so minus negative 4 plus or minus the square root of b squared is going to be negative 4 squared minus 4ac. A is negative 3, C is negative 4. And then we're going to divide the whole thing by 2a. Okay? Divided by 2a. Alright, 2a is 2 times negative 3. So from here on out, it's just arithmetic, or radicals, and also order of operations. So let's go ahead and simplify this. So we have x equals negative times negative is a positive. So we have 4 plus or minus the square root of negative 4 squared is 16. Remember, whenever you square negative, is a negative times a negative, and that's positive. And we have minus times minus is plus, times a minus is negative. Right? So minus 4 times 3 is 12. 12 times 4 is 48. Okay? And then that divided by 2a, which is negative 6. So let's focus our attention on simplifying the radical. Okay, so have 4 plus or minus 16 minus 48. Signs are different. Subtract and keep the sign of the bigger. So we have it's going to be negative 32 over negative 6. Now can we simplify this radical? Let's go ahead and do that on the left side here. Negative 32. First note that the minus comes out as an I because the square root of negative 1 is I. So let's break down the number. It's even, so we can take out a 2. 2 times 16 is 32. Take out another 2. It's 8. Take out another 2. That's 4. Take out another 2. That's 2. Okay, so we have 1, 2, 3, 4, 5, 2. So this can be reduced further. So every pair comes out as 1. So these two 2's can be factored out as a 2. And these other two 2's right here can be factored out as a 2. So the square root of negative 32 is equal to 2 times 2 is 4. These two come out, so they have pairs. 4i, because of the minus, comes out as an I, and you're left with just this 2's by itself, so it cannot come out of the radical, so it's 4i root 2. Okay, so let's put that into our expression here. So it's going to become 4 plus or minus 4i root 2 over negative 6. Okay, now what we're going to do next is we're going to simplify every single term. We're going to divide by the GCF of 4, 4, and negative 6. So what's the greatest common factor of 4, 4, and negative 6? The greatest common factor is 2. So we'll divide the numerator by 2 and divide the numerator by 2. Okay? Actually, since we have a minus downstairs here, we can divide by negative 2 so we can address the negativity in the denominator. So we divide by negative 2 and negative 2. Alright? So this becomes, if we divide this positive 4 by negative 2, it becomes negative 2. This becomes plus or minus, still stays plus or minus. And then divide this by 2, becomes 2i root 2. The radical stays the same, divided by negative 6 divided by negative 2 is 3. Alright? So there goes your final answer in a combined form. Okay? So there you have it. Alright, let's move along to question number 2. Question number 2, we're going to be looking at a composition example. So if f of x equals 3x squared plus 2x and g of x equals negative 3x squared, find f of g of x. Okay? Alright, so what on earth does f of g of x mean? Remember, f is the parent function because it comes first, and g is the input function. Okay? So what this is telling you is we're just going to take g, whatever the value of g is, and we're going to plug it into the x's in f. Okay? So we're just going to substitute the g's, whatever g is, into the x's in f. Alright? So to get this organized, we're going to write down our parent function first. The function that comes first is the parent function. So f of x equals 3x squared plus 2x. Now we're going to get it prepped for an input function. Alright? So to get it prepped, we need to clear all the inputs. On the left side, the name of the input is x. We're going to clear that out because it's about to change. And on the right side, these x's are going to be replaced by the value of whatever the input is here. Okay, so 3x squared, 3 parentheses square plus 2 parentheses. Alright, so replace all the x's with parentheses. The name of the input function is g of x. We're going to put that here. And then the value is negative 3x squared. So that goes into the open spots on the right side. Okay, so negative 3x squared on the left term, and on the right time negative 3x squared. Okay, alright, let's simplify this further. We're going to have this square affects the minus, the 3, and then the square. So we're going to have 3 times minus square is going to be a positive, so that minus goes away. 3 squared is 9, and then x squared is x to the 4th. Okay, so what we just did, let me rewrite my 4 properly. What we just did is basically used the power product of powers property to simplify this. So what happened is that this square went to the minus, made it a plus. This square went to the 3, made it a 9, and then this square went to the x squared, making it an x to the 4th. Alright, and on the right side here, this has no power. It could be 1, so it changes nothing here. So this minus can be multiplied by this plus, becomes a minus. 2 times 3 is 6, 6x squared. Okay, so let's simplify it further. 3 times 9 is 27, 27x to the 4th minus 6x squared is the value of f of g of x. Okay, so always keep track of the order. The one that comes first is the parent, and then the next one is the input function. Okay, so there you have it. All right, let's go ahead and try an example on sketching conics. All right, so for question number 3, sketch the graph of the conic with the equation x squared plus 9y squared equals 36. Now, can we predict what the conic is just by looking at this equation? We absolutely can. We notice that there are two squares, so anytime you have two squares, it's either going to be a hyperbola, a parabola, I'm sorry, it's either going to be a hyperbola, a circle, or an ellipse. Okay? The next thing you look at is the sign between the squares. If the sign between the squares is a negative, then it's a hyperbola. So this is a positive between the two squares, so it cannot be a hyperbola. It's either an ellipse or a circle. The next thing you do is look at the coefficients. If the coefficients are the same, it's a circle. If they're not, it's an ellipse. Coefficient here is 1. The coefficient here is 9. Different coefficients cannot be a circle, so this must be an ellipse. All right? So let's put this in the standard form of the ellipse, which is basically having it equal to 0. To accomplish that, we're going to divide both every single term by whatever the constant here is, which is 36. So divide the left side by 36, this term by 36, and divide that by 36. Okay? So that's going to yield x squared over 36 plus y squared over 4 equals 1. Okay? Now let's write this in the vertex form. So in standard form, so it's going to be x minus 0 squared over 36 plus y minus 0 squared over 4 equals 1. Okay? So since we're just graphing here, we just need to sketch up the graph. I'm just going to show you the center and the direction of the axis, and then we use that to generate our curve. Okay? So the center, simply take the opposite of the numbers next to the variables. So 0, 0 for the x and the y. Direction of axis. Direction of axis. Remember, for your ellipse, you have a major and a minor axis. Okay? So the number under the x-axis goes side to side. So when we root that number under the x, it's going to be 6, because the square root of 36 is 6. So we're going to go 6 units side to side. The number under the y is a 4. We take the square root of 4, which is 2. Since it's under the y, and the y-axis goes up and down, it's going to be 2 units up and down. Okay? So let's go ahead and sketch what our ellipse will look like. So there goes your y-axis, and the x-axis is centered right at the middle because my center is 0, 0. I'm going to exaggerate my y-axis a little bit longer so that I can have sufficient space to calibrate up to the value of 6. Okay? Alright, so let's do this. 1, 2, 3, 4, 5, 6 from the center. Actually, we're supposed to go side to side 6. Anyway, so 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So there goes the longer axis, known as the major axis. Side to side 6 units from the center. And up and down 2. So go down 1, 2. And then you go up 1, 2. Okay? And then you draw your ellipse as best as you can. Alright, so there basically goes the graph of your ellipse, okay? So let's label the axis. This is your y-axis. And this right here is your x-axis, okay? So there you have it. Alright. Now let's take a look at one last example. Basically the graph, we're going to graph a hyperbola. It's just a sketch. So for question 4, I'm going to graph x minus 1 squared divided by 4 minus y plus 2 squared divided by 9 equals 1. Okay, so this is a hyperbola. So we're not going to do a lot of labeling here. We're just going to do the basic hyperbola. Just graph the two curves um, using the center box and the asymptote. So let's go ahead and find where the center is first. So the center, we take the opposite of the numbers next to the variables. So opposite the x is a 1, and opposite the 2 is a -2. Okay, so there goes your center. Your central direction of central box. It helps us construct the asymptotes. That's going to be the square root of 4, which is 2. Where did the 4 come from? The x-axis, which goes side to side. So this 2 right here, what direction does it go? It goes side to side. Alright, and then the square root of 9 is 3. Since it's under the y-axis, the y-axis goes up and down. So where does this 3 go? 3 units up and 3 units down. So we're just going to use the center and these to construct our central box and asymptotes, and then we'll generate the curve after that. Alright, so we're centered at 1, -2. We go to the right and down, so our quadrant 3 is where, I'm sorry, quadrant 4 is where our graph will be centered on. So let's make quadrant 4 sufficiently large to compensate for that size. So there goes quadrant 4. Alright, let's graph the point 1, -2. So I'm going to go right 1 and then down 1, 2. So there goes the center. Okay, so we're going to go up and down 3 units. 1, 2, 3. Down 1, 2, 3. And then side to side 2 units. 1, 2. 1, 2. Okay, now let's create a central box and then draw the asymptotes. Okay, I'm going to draw this using a dotted line. So that it's not the actual curve. That's why I'm using a dotted line. Okay. All right. So there goes your central box, and then now we're going to graph the asymptotes. Okay. So to graph the asymptotes, what we're going to do, go through the diagonals basically and draw a line like that through the diagonals. Let's make the line sufficiently long. So going through the diagonals, those are my asymptotes. So that's going to guide the construction of my hyperbolas, okay? Alright, so there goes your asymptotes. Now, where does our hyperbola open? Well, since the x comes first, it's going to go in the x direction, side to side, okay? This minus means that the y component is gone, alright? So our hyperbola is going to be opening left to right, alright? So just get close to the asymptote, something like that. This is just a sketch. And then the other one goes like this and curves a little bit like that. Okay, let's do that again. So curves like this. It's much easier to do this by hand, like this, and then it goes like that. Okay, so there goes your hyperbola.